Swayam Prabha. Digital India. Educated India.
Hello everybody. Today we are going to start a new course on bioclimatic architecture, future proofing with simple and advanced passive strategies. So in this course, we will study about what is bioclimatic architecture. We will look at briefly the history of how this word bioclimatic architecture came, because we are using several terms these days: vernacular architecture, sustainable architecture, bioclimatic architecture. We will look at the history of it, and we will also see what are the strategies in order to make our buildings sustainable, by using the principles of bioclimatic architecture. So, today we will look at what is bioclimatic architecture, a brief introduction about it. Today's class will be on this. So, we will look at what is bioclimatic architecture. In this lecture, we will explore bioclimatic architecture, which combines eco-friendly building materials with smart design. We will cover its basic principles, why it is important, and the benefit it brings, such as saving energy and creating healthier spaces. We will also look at real examples to see how it works in practice. While there are challenges, we will also discuss exciting future trends that are making our buildings even more sustainable and comfortable. By the end, you will have a better grasp of how bioclimatic architecture is shaping the future of building construction. Now, bioclimatism is a design concept in architecture that takes into account the relationship between a building, its systems, its natural environment, mainly through its, say, microclimate and its occupants, especially in connection with human thermal comfort conditions. So, if you actually see what is bioclimatic architecture, a combination of. So, you need to relate architecture, you need to understand the climate of the place, which we will be looking at in this course. How do we understand the climate of a place? You also need to understand the biology of the occupants, and this is where we can say thermal comfort, what comprises it. These are important in order to understand bioclimatic architecture, and also the technology. So, a combination of all these together comprises bioclimatic architecture. But in order to understand the principles of what will govern bioclimatic architecture, these two are very important, and therefore we call it as the current context: climatology and the biology of the occupants, which is the thermal comfort requirement. What environment makes the occupants feel more comfortable? So, bioclimatic architecture is combining biology and climate, and it is a design approach that prioritizes creating buildings and spaces that harmonize with the local climate. It is rooted in the understanding that buildings can be designed to work in harmony with nature, leveraging natural elements to create comfortable and efficient living spaces. One of the fundamental principles of bioclimatic design is the strategic use of passive solar system, which harnesses the sun's energy for heating, cooling and lighting purposes. This includes features like south-facing windows for winter solar gain and shading elements to mitigate summer heat. Natural ventilation is another cornerstone, promoting airflow and reducing the need for mechanical cooling systems. Additionally, bioclimatic architects, they integrate sustainable building materials with thermal mass properties, enabling structures to absorb and release heat gradually, thus stabilizing indoor temperatures. This holistic approach not only enhances occupant well-being but also contributes to the overall sustainability and resilience of the built environment. In short, bioclimatic architecture refers to the design of buildings and spaces, that is, interior spaces, exterior or outdoor spaces, semi-enclosed spaces, etc. But it must be based on the local climate, and it is aimed at providing thermal as well as visually comfortable environment by making use of passive solar system like solar energy and maybe some other environmental sources. What are these? We will look at in the further classes. The basic elements of bioclimatic design, they include the solar passive systems, which when incorporated into buildings can utilize the environmental sources such as the sun, breeze, vegetation. We can use even water, soil, sky, etc. for heating, cooling and lighting the building. Natural ventilation, solar heating and shading, and the use of building materials for thermal time lag and storage, these are small examples of bioclimatic design techniques. Now, bioclimatic architecture, we will look at the principles. According to Lamberts, what he says is bioclimatic architecture. So, bioclimatic architecture and buildings, they first have to respect the environment. So, bioclimatic architecture is a way of designing buildings based on the local climate with the aim of ensuring thermal comfort using environmental sources. We had already seen in the previous slide, bioclimatic architecture is a combination of climate, to be very specific, local climate of the place, plus the biology or the bio of the occupants. In our case, what we mean by this is all that governs the comfort conditions required by the occupants. So, we can combine climate and bio of the occupants by making use of environmental factors. So, what are the environmental factors? They are the sun, wind, vegetation, water body and sky conditions too sometimes. You combine all these to optimize indoor comfort, daylighting, etc. This is the basis on which Lamberts defines bioclimatic architecture. So, principles of bioclimatic architecture according to Lamberts is that bioclimatic architecture is guided by several fundamental principles. Building thermal performance stands out as the cornerstone, emphasizing the importance of efficient insulation and envelope design to regulate internal temperature and minimize energy consumption. This is in the Western context and therefore we talk more on insulation. If we look at the Indian context, especially in the tropics, then we will not look at insulation in order to keep the indoors warm. We will look at primarily making the indoors comfortable based on the climate parameters, because India has all kinds of climate. Only in the cold regions this is valid. Daylighting is another key principle, promoting the integration of natural light to reduce reliance on artificial lighting and enhancing visual comfort. Heating and passive solar cooling techniques are utilized to harness solar energy for warmth in winter and natural cooling in summer, contributing to overall energy efficiency. Natural ventilation strategies are also prioritized to ensure adequate airflow and indoor air quality, complemented by measures for thermal comfort and proper shading to maintain an optimal environmental condition throughout the year. Now let us look at what Axerly and Telly talks about as principles of bioclimatic architecture. Axerly and Telly further expand on bioclimatic principles, emphasizing the achievement of thermal comfort as the primary goal. This involves designing spaces that maintain consistent and comfortable temperatures for occupants, improving visual comfort through effective daylighting strategies, minimizing on glare and optimizing lighting design, which becomes very crucial. Acoustic comfort is addressed by utilizing sound absorbing materials and layout considerations to create peaceful indoor environments. Additionally, efforts are made to enhance air quality through ventilation systems, air filtration, and green building practices, while also focusing on improving the overall energy efficiency measures and renewable energy integration. EDP energy contributes to the principles of bioclimatic architecture by highlighting the importance of microclimate improvement. This involves designing interventions that enhance local microclimate, making outdoor spaces more comfortable and livable. Systems and passive cooling techniques are employed to reduce reliance on mechanical cooling, utilizing natural elements like ventilation, shading, and thermal mass for energy. This creates an energy efficient climate control. Solar energy exploration, it plays an important role with designs incorporating solar radiation for heating, lighting, and power generation. Thermal protection of buildings and shading strategies are integrated to manage heat gain and ensure thermal comfort. Finally, emphasis is placed on natural lighting solutions and acoustic protection measures to create harmonious and sustainable built environments. So, according to Axkerley and Telly, thermal comfort is a very important criteria in bioclimatic architecture. Adequate shading, is another important criteria as and when required. Visual comfort through use of appropriate color, temperature, daylighting levels is important. Acoustic comfort becomes very important. Improved air quality, improved building energy efficiency, improvement of microclimate, and use of solar energy. So, these are the 8 principles of bioclimatic architecture according to Axerly. I repeat, first is the thermal comfort. The 8 principles of bioclimatic architecture, they are thermal comfort, adequate shading of fenestration. It means allowing adequate or appropriate amount of sunlight inside the building. Visual comfort, improving the daylighting so that the harsh glare is cut and good diffused lighting levels are brought inside with adequate levels of illuminance. Acoustic comfort, providing adequate insulation or buffer areas with the help of vegetation. Then improved air quality. Again, vegetation can play a very important role in it. Sixth is improved energy efficiency, leading to sustainable architecture. Next is microclimate. So, microclimate has to improve, which means we cannot use the outdoors as a heat sink. If you do that, then the indoors will become comfortable, but the microclimate will go for a toss. So, microclimate improvement is important, which means we are looking at the environment holistically. And last is use of solar energy or any energy which the environment is giving, such as even wind energy. Now, let us look at the significance of bioclimatic architecture. Bioclimatic architecture is significant for several reasons. Energy efficiency, this is one of the primary advantages, and this is the focus which maximizes natural resources like sunlight and wind for heating, cooling and lighting buildings. This reduces the reliance on artificial heating, ventilation and air conditioning, which is HVAC systems, leading to lower energy consumption and operational cost. The second important thing about bioclimatic architecture is the environmental sustainability. Bioclimatic design aims to minimize the environmental impact of buildings by reducing greenhouse gas emissions associated with energy use. By optimizing natural ventilation, passive heating and cooling, and using renewable energy sources, bioclimatic architecture contributes to sustainable development goals. The third significance is the comfort and well-being. Bioclimatic buildings are designed to enhance occupants' comfort and well-being by providing a healthy indoor environment with adequate and sufficient natural light, along with good quality of light, which means there is no harsh glare, adequate thermal comfort and good indoor air quality. This can lead to increased productivity, better health outcomes and overall satisfaction for building users. So, the first importance or significance is the energy efficiency measure, and because of having an energy efficient building, there is reduced demand for heating, there is reduced demand for cooling, there is reduced electrical demand for lighting, there is reduced electrical demand for water heating, good housekeeping and people solutions emerge, and reducing the energy requirements for ventilation happens. Then the second one is the environmental sustainability. This becomes important because by making the building environmentally sustainable, greenhouse gas emissions get reduced. Now we know that buildings account for about 39% of greenhouse gas emissions, and out of this 28% is for building operations. So, in order to make a building run, in order to make the building functional, after it is built, at least 28% of the energy is consumed towards it. This is completely in the hands of the architect, and due to architectural design, this 28% can be reduced. 11% of greenhouse gas emissions happen because of embodied carbon from the building material and construction industry. This is a construction stage or early design stage decision taking, and this we will not focus on this time, whereas the operational energy reduction is possible because of an energy efficient building designed through bioclimatic principles. And then third is, finally, it's most important that the person who uses the building finds himself comfortable. Comfortable thermally, daylighting wise, visually, acoustically, and through all other means. He must find it very comfortable to stay in the building. The other significance include resilience to climate change. So, with the increasing challenges posed by climate change, bioclimatic architecture offers solutions that can improve resilience to extreme weather events, reduce vulnerability to heat waves or cold spells, and adapt to changing climatic conditions more effectively than traditional building designs. The fifth significance is the cost savings. Over the long term period, bioclimatic buildings can save significant costs related to energy bills, maintenance, and upgrades. While initial construction cost might be significantly higher due to specialized design features, the ongoing savings and benefits will outweigh these expenses. The next significance is the cultural and contextual integration. Bioclimatic architecture often integrates local climate conditions, cultural traditions, and vernacular architecture principles. This results in buildings that are contextually appropriate, aesthetically pleasing, and harmonious with the surroundings, fostering a sense of place and identity. Overall, the significance of bioclimatic architecture lies in its ability to create sustainable, comfortable, and resilient built environment that aligns with ecological, social, and economic goals. So, the fourth aspect of bioclimatic architecture is the resilience to climate change. We know that climate change is a reality, and we all are bearing the brunt of climate change. Being in the tropics, it is even more visible, and we have to also see whether the world is prepared to host what is called as climate change refugees, because already some small islands are getting submerged. Now, where will people who live there go? They will have to be given a shelter or refuge by some other country. So, we have to see whether the world is prepared for such situations, which is a reality. By designing buildings as per bioclimatic architecture, as we saw in the previous slide, we can have control on the 28% of GHG emissions which happen because of the operation of the building, and therefore we can slow down climate change. The fifth one is cost savings in every way, because if energy is saved, costs are automatically saved apart from all the other hidden costs. And then being culturally and contextually relevant. So the building does not look at like an eyesore, and we also do not lose a piece of history or tradition in the process of designing. Now, let us look briefly at the history of how this bio-inspired architecture came, because there are so many terminologies that we come across today. So first, what was is prehistoric architecture. Now, this was the simplest form of climate adaptation in architecture, where the prehistoric occupant just wanted a shelter to protect himself from the climate. Then came what is called as the vernacular architecture. Now this architecture has some adaptations to local, natural and social conditions, because by then man had also become a social animal. Third is bio-inspired architecture and technologies. So in this process, there was some kind of exploration which culminated in organic style of architecture, which is inspired by nature and it adapts to local environment and conditions. Now this happened during the late 19th and early 20th century up to present time, from the beginning of Antonio Gaudi's work. Then fourth is organic architecture. Now this is a philosophy of architecture which promotes harmony between human habitation and the natural world. This reduces the need for using energy and resources. This term was coined by F.L. Wright, as we all know, who was a very influential architect, and this principle was largely based on his observation of nature. As he grew up on the farms of his grandparents, he was able to observe nature very closely, and he tried to use those principles or translate it into architecture at a later date, which was called as organic architecture. And then came what we are studying here in this course, which is bioclimatic architecture. So this talks about passive design solutions that adapt to climate comfort to create indoor comfort. So this talks about passive design solutions which adapt to climatic considerations to create indoor comfort, satisfying better demands of occupants' needs. And this started in around mid-20th century. After that came the term passive and low energy architecture. This employs advanced design techniques to build more energy efficient and more comfortable buildings. This trend has partly evolved towards creating zero energy buildings, started in around 1980s. Then came the word or the concept of green buildings, where buildings respectful for their natural environment and strictly controlling their environmental impacts to the building's entire life cycle system, while it also maintains good indoor comfort for occupants. This came towards the end of 20th century. And now the future is in sustainable architecture and regenerative architecture. So, sustainable architecture is meeting the needs of present generation without compromising the ability of future generation to meet their needs, while balancing the environmental, social and economic issues in the building design. Whereas regenerative architecture talks about giving back more to the environment than what is taken. So, producing energy in excess of the consumption is regenerative architecture. Now, let us briefly look at the evolution of bioclimatic architecture, the way we would want to take this course. So, we have seen vernacular architecture, which is the simplest form of climate adaptation in architecture, which is usually done by using locally available materials to build shelters. Architecture has some adaptations to local natural and social conditions. This has evolved along the history. Then we have the bio-inspired architecture and technologies. This culminated in an organic style of architecture which is inspired from nature, adapting to local environments and conditions. Then from the late 19th and early 20th centuries up to present time, this started with the work of Antonio Gaudi, and then we had what is called as organic architecture. This is a philosophy of architecture which promotes harmony between human habitation and the natural world, reducing the need of using energy and resources. This term organic architecture was coined by F.L. Wright, who is a very influential architect of the 20th century. And then the bioclimatic architecture, which is what we are looking at. So this looks at passive design solutions which adapt to climatic conditions to create indoor comfort, satisfying better demands of building occupants, and this is used since the mid-20th century. And then comes the passive and low energy architecture and green architecture, as we have already seen. So this period, if you see how it is periodically evolving, the green architecture leads to sustainable architecture, architecture about sustainability, architecture for sustainability, architecture as sustainability, and then it culminates, or the future is in regenerative architecture. Regenerative architecture, it looks at a building method that uses and regenerates from the surrounding ecosystem. Architecture that co-evolves as a single entity responds to and uses the natural and biological systems that were already located on a site. The importance of the project site and the environment is recognized and emphasized by regenerative design. So, we will look at the challenges of bioclimatic architecture. The first is limited awareness and understanding. So, one of the primary challenges is the lack of awareness and understanding among architects, designers, and the general public about the principles and benefits of bioclimatic architecture. This can lead to resistance or hesitation in incorporating bioclimatic strategies in the building design. The second is the cost and investment. So, implementing bioclimatic strategies often requires upfront investment in technologies, materials, and design considerations that can be perceived as costly. While these investments often pay off in long-term energy savings, the initial capital outlay can be a barrier for some projects. The third is regulatory and code constraints. Building codes and regulations in some regions may not fully support or give incentives to bioclimatic design principles. This can limit the flexibility of architects and designers to implement innovative bioclimatic strategies. The fourth is the technical complexities. Now, bioclimatic architecture involves complex considerations such as climate analysis, passive design strategies, and integration of renewable energy systems. Designers and architects may face technical challenges in optimizing these strategies for different climate zones and building types. The fifth is maintenance and performance monitoring. Bioclimatic buildings require regular maintenance and performance monitoring to ensure that passive and active systems continue to operate effectively. Lack of proper maintenance can lead to decreased performance and energy efficiency over time. Sixth is material availability and suitability. Availability of sustainable and eco-friendly building materials that align with bioclimatic principles. These can be limited in some markets. Finding suitable materials that meet both performance and environmental criteria can be a challenge. Seventh is behavioral factors. The success of bioclimatic design also depends on user behavior and occupant engagement. Inefficient use of building systems or disregard for passive design features can undermine the effectiveness of bioclimatic strategies. Addressing these challenges requires a multidisciplinary approach involving architects, engineers, policymakers, and stakeholders to promote awareness, improve regulations, enhance technical expertise, and encourage sustainable practices in the built environment. So, In this class, we saw an introduction of bioclimatic architecture, what its principles are and what it encompasses. We also saw its challenges. With this, we will stop today's class and continue with the next class. Thank you.